Hi guys, welcome to Piece of Code and welcome to this video. So in this video, we do what we do, solve more questions. So without, wasting more time, let's get on with the questions. So the first question says that a solutions architect, okay, I need to draw, so let me just select my uh, pen with red and this guy. Fine. A solutions architect configured a VPC that has a small range of IP addresses. The number of Amazon EC2 instances that are in the VPC is increasing, and there is an insufficient number of IP addresses for future workloads. Which solution resolves this issue with the least operational overhead? So, what does this question, mean basically? So VPC is running off IP addresses. So what do we need? We need more IP addresses, right? Simple as that. And the goal is to have minimal operational overhead. We don't want to do any more heavy lifting, no complex things, whatever, whatnot, right? So let's go through the option which is better. A says that add an additional IPv4 CIDR block to increase the number of IP addresses and create additional subnets in the VPC. Create new resources in the new subnets by using the new CIDR. So this actually, seems like a very good option. So for now, I'm going to mark it as correct. Why? Because what you are doing is basically adding another CIDR block. And by adding, more CIDR block, basically you are, expanding your range of IP addresses. It's as simple as that. It's simple networking, right? So it's done within the same VPC, and you are not adding any more complex things, and it's a minimal operational overhead, right? Just add the block and keep deploying resources as you would normally, right? So that is what it needs, simple and perfect. I think this is what I would go for in this particular option. Okay. Now, talking about option B says that creating a second VPC, but that is not needed, and that will be, creating more, complexity. You have to use VPC peering and do some stuff here and there, which is not needed. So I'm not going to go with B. C is even more complicated, right? I mean, transit gateway, it says that to add a transit gateway and connect a second VPC with the first VP update and the routes of the transit gateway and VPCs, create new resources in the subnet of the second VPC. So basically, I mean, you are dealing with many VPCs and complex networks. In that case, you are going to use a transit gateway, but just for adding IP addresses, if you want to use all this circus, and basically it's not going to work, and it's going to work somehow, but you're making it complicated. That's it. We don't want any complicated things. D also says to create a second VPC and do some agadam digadam. I don't want to do all that stuff. So I'm not going to go with D as well, right? It's a very simple. A is the correct option, right? If you have any questions, you can put it in the comments, you know, and we are going to solve it anyways. Question number 122. Now, this question says that a company used an Amazon RDS for MySQL DB instance during application testing. Before terminating the DB instance at the end of the test cycle, a solutions architect created two backups. The solutions architect created the first backup by using the MySQL dump utility to create a database dump. The solutions architect created the second backup by enabling the final DB snapshot option on RDS termination. The company is now planning for a new test cycle and wants to create a new DB instance from the most recent backup. The company has chosen MySQL compatible edition of Amazon Aurora to host the DB instance. Which solution will create the new DB instance? Which solutions will create the new DB instance? So we have to choose two options over here. So what does the particular question tell us? Basically, um, there are two types of backups over here. One is this by using the MySQL dump utility, and another one is the RDS snapshot, TB snapshot on the RDS termination, right? So this is what they have. So they are switching from RDS MySQL to Aurora MySQL, right? And basically what are the steps to, migrate to Aurora completely. That's what it needs, right? So option number says that import the RDS snapshot directly into Aurora. So it seems like a very simple option, and you would think that as both are AWS services, it might be compatible, but this is not how it works. RDS snapshots are not directly importable into Aurora, right? Aurora doesn't speak that snapshot language, okay, where you just import the snapshot and voila, you have a new database of Aurora. So it needs something differently. Now, you can restore an RDS snapshot into RDS itself, into a new RDS DB, but you cannot directly use it into Aurora. You have to do something in between. So I'm not going to go with that, right? It seems simple, but you know, you have to also consider the, if it is working or not as well. Option number B says that upload the RDS snapshot to Amazon S3, then import the RDS snapshot into Aurora. I mean, it's the same thing. Aurora does not import snapshot. You cannot use Aurora snapshot. Anyways, you cannot use a snapshot, right? So it doesn't make any sense over here to just uploading a file to S3, which is not going to work. Upload the database dump to Amazon S3, then import the database dump into Aurora. Now, this seems like a very good option to start with. Why? See, MySQL dumps can be uploaded to S3, first of all. You can upload anything to S3. And you can use any, Amazon RDS or Aurora tools to import them. That is possible. But RDS snapshots, that is not possible. So it's very easy to use, and Aurora MySQL compatible editions support this importing of data from S3, like this MySQL dump that you are doing, right? So basically that is going to work. So C is a very good option in this case. Option number D says that use DMS data migration service to import the RDS snapshot into Aurora. So basically DMS doesn't work with snapshots, right? DMS is used for live data migration from databases, not static snapshots. So you have one database in your on-premise, and you want to migrate it to the AWS, for example. So in that case, you can use DMS, right? So, but in this case, it is not going to work. So we are left with E. So that should be the perfect option. So E says that upload the database dump to Amazon S3, then use DMS to import the database dump into Aurora. So this makes sense. Why? DMS, as I told you, that DMS doesn't import directly from dumps, but you could restore your dump into a temporary RDS MySQL instance, right? That is a live database, as I told. You can use DMS to migrate between two databases, right? And then if you, I mean, you just your temporary RDS MySQL instance you create and use DMS to migrate it into Aurora, right? And uh, then what you do is, you can use it. Simple as that. I don't have anything else to say because this seems like a pretty um, good option, right? Yeah, it includes some steps in between, right? It's a little bit more trickier to understand, but it will work because you are not directly using the snapshot. See, snapshots are not compatible. First of all, to just get, even if you don't know the, steps in between, like I told that you can restore it to a temporary RDS instance and then use DMS. That might be a little bit far-fetched, right? You can use a lot of other things. But one thing to keep in mind is that RDS snapshots are only compatible with RDS, right? So basically, you can do a lot of things, right? And RDS snapshot, you cannot directly import it, into Aurora, or you can't use DMS to work with RDS snapshot. So that's what it is. Okay, so let's move on to question number 123. And this question says that a company hosts a multi-tier web application on EC2 instances. See, one more thing I want to tell you that I might be wrong. I cannot get all of the answers correct, right? If I am wrong, then you can correct me. It's okay, right? So that's the thing. A company hosts a multi-tier web application and on EC2 instances behind an application load balancer. The instances run in an auto-scaling group across multiple availability zones. The company observes that the auto-scaling group launches more on-demand instances when the application's end users access high volumes of static web content. The company wants to optimize the cost. What should a solutions architect do to redesign the application most cost effectively? So what does this, scenario dictate to us, right? So you've got a multi-tier web app on EC2 instances behind an application load balancer. It's in an auto-scaling group across multiple AZs, right? Let me just bring the diagram up over here. So AZ1, AZ2, and AZ3, so that you will remember at least. I know this is very bad as terms of drawing, but it's fine. You guys can understand. So you're noticing that more on-demand instances are spinning up when there is a high volume. So obviously our goal is to optimize cost, right? So what we should do. So option number A says that update the auto scaling group to use reserved instances instead of on-demand instances. Now reserved instances save money for predictable workloads, right? But they don't address the underlying inefficiency, right? In this case, it is not needed to use reserved instances because it doesn't ask if this is a predictable workload, it will run for a couple of years or something like that. So reserved instances is out of the question. And you are also still serving files, static files with EC2, and you would need more compute power in during spikes, right? But in reserved instances, you will define that, okay, I need this much compute resource or I need this much, storage resource, and that's it, right? You're not going anywhere with this. So I'm not going to go with A. B says that update the auto scaling group to scale by launching spot instances instead of on-demand instances. Now, this is a very nice idea about optimizing costs, but it's not best for this use case. Why? As spot instances can disappear anytime, and you're serving static content to the end users. When there are end users involved, you should not use spot instances. Spot instances are basically for background jobs like batch processing or workloads which can handle termination, and it can resume after a specific point of time. In that case, you would use spot instances, but here this is not a very good option. C says that create a CloudFront distribution to host the static web contents from an Amazon S3 bucket. Absolutely flawless. Flawless option. So basically, this is how you optimize static content, right, in AWS. I mean, using AWS to serve static content is like you are going into, you know, um, I don't know. I wanted to give you an example, but then I lost my train of thought. So I'm not be able to give you that example anymore. But anyways, so if you have CloudFront, it's very idiotic to use EC2 instances for static content. It's simple as that, right? Because CloudFront solves everything when it is coming to static content and there is end users involved. The end users are all over the world. So you can use edge locations, which is used in CloudFront to serve them the static content. So simple. Now, D is even more stupid. It says a Lambda function API gateway to host the static website contents. Not gonna even explain that. Next question. Company stores several petabytes of data across multiple AWS accounts. The company uses AWS Lake Formation to manage its data lake. The company's data science team wants to securely share selective data from its accounts with the company's engineering team for analytical purposes. Which solution will meet these requirements with the least operational overhead? So, what does this particular question means? Basically, you have several petabytes of data across multiple AWS accounts. Company uses lake formation to manage its data lake. company's data science team wants to securely share the selective data from its accounts with the engineering team, right? That's what it means. So, what should we do with the least operation overhead? So this is something to do with the access basically, and somehow you have to use IAM, right? And you have to deal with roles or users or whatnot. But we'll see in the options what this particular, question gives. So A says that copy the required data to a common account, create an IAM access role in that account, grant access by specifying a permission policy that includes users from the engineering team accounts as trusted entities. Now, it's a very high operational overhead, in my opinion, right? Um, because you have to duplicate the data. So basically, you're saying that copy the required data to a common account, right? So you are duplicating the data, then you are creating access role in that account. So you are also managing roles over here. And you have to also maintain the sync between the accounts, right? I mean, it's not the best use of lake formations attributes because there is something in lake formation that you can use directly to share this data with the engineering team. So I'm not going to go with A. I was wrong actually. IAM might not be the best solution over here, but I kind of forgot that we have a very good option in lake formation to achieve this. But anyways, we will see. So option number B says that use the lake formation permissions grant command in each account where the data is stored to allow the required engineering team users to access the data, right? Now, this is a manual effort, right? I mean, for multiple accounts, it becomes operationally very heavy. I mean, to do this, right? Which we can easily, make it a little bit more automated. So I'm not going to go with B for that particular reason. C says that use AWS Data Exchange to privately publish the required data to the required engineering team accounts. Now, data exchange is generally used for, sharing data products with external parties, right? Not internal. If you want to share data internally, then AWS Data Exchange is not a very good option. And you are also doing it within the same organization, just across different accounts, right? So in this case, data exchange is also not going to work. And we are left with only D, which says use lake formation tag-based access control to authorize and grant cross-account permissions for the required data to the engineering team accounts. And in my case, this is best because in AWS lake formation, there is this tag-based access control. Okay, we call it as LFT back, right? So it allows you to centrally manage fine-grained access to your data by assigning this LF tags to your data assets like your databases, tables, or columns, right? Now, you can grant this cross-account permissions using these tags, and it's very simple and scalable, especially when multiple AWS accounts are involved over here. And there are a lot of data. Here, if you see, there are several petabytes of data. Okay, it's secure, scalable, and it's designed for exactly this use case where you have to, share a lot of data with the other teams, right? So let's move on to the next question. Okay, guys, so let us see question number 125. Let me just get my pen over here, and this is perfect. Okay. So it says that a company wants to host a scalable web application on AWS. The application will be accessed by users from different geographic regions of the world, right? The okay, it's wants to host a scalable application on AWS first of all, right? Application users will be able to download and upload unique data up to gigabytes in size. The development team wants a cost-effective solution to manage to minimize the upload and download latency and maximize performance. So the first option says that The we should use Amazon S3 with transfer acceleration to host the application. Now, um, this sounds good because using S3 with transfer acceleration. So transfer acceleration will help you in increasing your upload and download speeds, and S3 will be used to store your files or your application. But wait a minute, what does it say? It says S3 and transfer acceleration to host the application. Hmm. Here's the catch. Now, till S3 and transfer acceleration, if that was being used separately apart from the application being hosted. So what do I mean is that S3 is not meant to host a fully functional web application. It is great for storing static files like downloadable content or images, videos, whatever, right? It's not a web server. So you can't run server-side code or host some dynamic content on S3. So if the this option a little bit confusing. Why it is a little bit confusing? It will attract you towards this option because it says transfer acceleration with S3. Now in S3 you can use it separately just to store the files. If that was the case, then this is the correct option. But it is saying to host the application. I think there should be much more better option which will give you a better solution to host the application, right? And they need a scalable web application on AWS. So in my opinion, I might not go with this A option, but if you have so many other opinions, you can, give me. B says that use S3 with cache control headers. Now, this is same thing. We are using S3 to host the application, but we are using cache control headers. So what are cache control headers? So cache control headers basically are used to control how long content is cached by the CDNs, right? It just means that if there is something that is repeatedly being requested by the end user, it can help reduce latency for those requests. And it is great for static content. But again, S3 is not a web server, right? So I'm not going to go with S3. It says use Amazon EC2 with auto scaling. Number C says that, and Amazon CloudFront to host the application. Now, EC2 with auto scaling. This is a better option to host the application. Now, it is not the best option available in AWS, absolutely perfect. You can use any other like ECS or any other Kubernetes service to actually host your application, but this is what we get over here. So we get Amazon EC2 with auto scaling. It can easily scale up. So you can build a scalable web application, right? That is what the question is asking. And you are using CloudFront to host the application, right? So you have CloudFront as your CDN. It caches your content at the edge locations all around the world, and it's perfect for a global user base. Now, for downloading and uploading large files, CloudFront can help optimize those transfers as well. It will make them faster and also it will be more efficient, right? So I would say that C, in my opinion, is a correct option, right? But let us also give a chance to D. It's saying Amazon EC2 with auto scaling with elastic cache. Now, elastic cache is not the right option in here because it's powerful, but it's not what you need here. You have to do a lot of stuff. I mean, but so I'm not going to go with D. So, in my opinion, C is the correct option, right? Let's move on to the next question. I know this is a little bit confusing with the options. Maybe the wording is not correct, I would say, but still you have to choose some option, right? So that's what it is. Question number 126. This says that a company has hired a solutions architect to design a reliable architecture for its application. The application consists of one Amazon RDS DB instance and two manually provisioned Amazon EC2 instances that run the web servers. The EC2 instances are located in a single availability zone. An employee recently deleted the DB instance and the application was unavailable for 424 hours. How did he delete that? That's the first question I would ask. Anyways, The company is concerned with the overall reliability of its environment. What should the solutions architect do to maximize reliability of the application's infrastructure? Okay, so this employee did some stupidity, so we have to do all this things. Company has an application, one RDS DB instance and two manually provisioned EC2 instances, right, which are the web servers. Now, this is in a single availability zone. That is also we have to keep in mind. Employee accidentally did some stupidity and deleted the DB instance. Now, company is worrying about the reliability of their infrastructure. So, what should we do to maximize the reliability? Let's see. Option number A says that delete one EC2 instance and enable termination protection on the other EC2 instance. Update the DB instance to be multi-AZ and enable deletion protection, right? So, what does it say? Basically, delete one EC2 instance. So why would we delete an instance, first of all? The company already has two instances, and deleting one would, obviously reduce the capacity. It doesn't make any sense. And it's you are like going away from the reliability concept, right? Enabling termination protection on the other EC2 instance. Now, termination protection is a good idea. It provides this accidental termination of the instances, but this alone doesn't solve the bigger reliability issue. So I'm not going to go with A. That doesn't make any sense to me. So I'm just going to go to the next option. So B says that update the DB instance to be multi-AZ and enable deletion protection, right? Place the EC2 instance behind an application load balancer and run them in an EC2 auto scaling group across multiple availability zones. I think this is, very good option, and I would say that this is, in my opinion, is the correct option. Why? Let's discuss. First of all, update the DB instance to be multi-AZ. This ensures high availability across the different availability zones. Simple as that. Second of all, deletion protection. You're also doing deletion protection, right? What does it do? It will prevent the accidental deletion. If some other stupid employee tries to do this, no, sir, you don't have the right to do it. Place the EC2 instance behind an application load balancer. Great idea. I mean, a load balancer eventually distributes the traffic across instances and it can route the traffic more effectively. Then we put them under an auto scaling group across multiple availability zone. Auto scaling groups, it ensure that there are the right number of instances running to receive the load and spreading them across the multiple AZs. It just improves your fault tolerance and it checks all your boxes. So this is perfect. I would say B is the perfect solution. Then comes C, says that create an additional DB instance along with the API gateway and Lambda function. This is just too much to do. I mean, you have to do with whatever you have. You don't have to entirely change whatever you have, right? I don't want to change my entire, uh, you know, infrastructure. So I'm not going to go with C over here. D says that place the EC2 instance in an EC2 auto-scaling group that has multiple subnets located in multiple availability zones. Use spot instances instead of on-demand instances. Set up CloudWatch alarms to monitor the health of the instances, blah, 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 whatever it is trying to do. Now, first of all, if you place it in auto-scaling group EC2 instances, this is fine. But using spot instances instead of on-demand instances. Spot instances are cheaper, but they can be terminated at any time. So for a production application, you don't want to do this stuff. Setting up CloudWatch alarms, I mean, monitoring is always good, but it's not directly related to your reliability issue. So I'm not going to go with D as well. Right? I hope that is making sense, guys. If you have any questions, you can put it in the chats. Question number 127. Question number 127 says that a company is storing 700 terabytes of data on large network attached NAS system in corporate data center. The company has a hybrid environment with a 10 Gbps AWS direct connection. After an audit from the regulator, the company has 90 days to move the data to the cloud. The company needs to move the data efficiently and without disruption. The company still needs to be able to access and update the data during the transfer window. Which solution will this particular, we have to check which option is correct. So option number A says that create a data sync agent, right? And in the corporate data center, create a data transfer task, start the transfer to an S3 bucket. I would say that this is absolutely perfect, but we'll also go through the option. But why do I consider this as perfect? Because data sync, I've told this numerous times, it's designed for that fast data transfer between your two sources, like your on-premise storage and your AWS. It is also good for large scale transfers, right? Like this particular question demands. And it will also handle your continuous updates, whatever you are doing in your on-premise system as well. So data sync agent, you install this data sync agent in your on-premise to facilitate the transfer, right? That's why the data sync agent is also important over here. But even if you don't know about the data sync agent, as your eyes fall on this absolutely brilliant service, which is data sync, you should be attracted towards that option, and rightfully so, right? So next is option number B, says that backup the data to AWS Snowball Edge storage optimized devices, ship the devices to an AWS data center, mount a target, um, you know, Amazon S3 bucket on the on-premises file system, um, and whatnot. So Snowball, any kind of Snowball device, we use it for very large scale data transfer. You load it and then ship it to AWS, and then you load it back into some AWS like S3 service, right? Um, this can also handle your terabytes of data, like 700 terabytes of data, right? Whatever it is. So 700 terabytes is not a problem, and mounting it on a S3 bucket also is making sense. But why it will not work in this case is that Snowball is great for your one-time transfers. Like if you want to transfer as a bulk, you would do that. And it's an absolutely masterpiece of a solution to do that, right? It doesn't support your continuous updates. That is the crux of the question. We cannot support the continuous updates thing that this particular question demands during the transfer window, right? So once you ship the device, that's it. Any more updates, it's not going to get synced, right? So I'm not going to go with B for that particular reason. C says that use resync to copy the data directly from local storage to to designated Amazon S3 bucket over the direct connection. rsync, it's a command line tool for synchronizing files between your systems, right? It's also great for incremental updates as well. But in this case, we already have data sync, so we don't need this actually. So I'm not going to go with that. Backup the data on tapes. Why will you use tapes? Doesn't make any sense. If you want to ship the data, you should consider Snowball itself. I mean, why do you use tapes? That's stupid. Anyways, let's move on to the next question. Company stores data in PDF format in Amazon S3 bucket. The company must follow a legal requirement to retain all new and existing data in Amazon S3 for 7 years. Which solution will meet these requirements with the least operational overhead? So basically, what does this particular option says that sorry question says that we have to ensure that data is retained for 7 years, and we should not allow early deletions, and it should apply to both new and existing data, and we have to do it with the least operational overhead, right? So A says that turn on S3 versioning feature for the S3 bucket, configure S3 lifecycle to delete the data after 7 years, configure multi-factor MFA, delete for all S3 buckets. Now S3 versioning, it helps to keep multiple versions of an object. So if someone deletes or overwrites a file, the old versions are still there, right? But it's not good for protecting against accidental deletions. It doesn't enforce like a legal hold on the particular data. Someone could still delete if they want, right? If they have the permissions, they'll be able to delete it. So using versioning over here is not a good option, right? So I'm not going to go with A. Option number B says that turn on S3 object lock with governance retention mode for the S3 bucket. Set the retention period to expire after 7 years. Recopy all existing objects to bring the existing data into compliance. So governance, sorry, first of all, S3 object lock. This particular feature prevents object from being deleted or overwritten for a specified retention period. But hold on, governance mode. That is the problem over here. When you go with governance mode, it allows overrides, which means that the retention policy, it's not immutable. Okay, this might not meet your legal requirements, right? Which is asked in the question. So recopying, and also you are recopying all the existing data, right? All the existing objects. It adds the, whatever the operational overhead. So we are not going to go with B as well. C says that turn on S3 object lock with compliance retention mode on. Fine. This is now making sense. Set the retention period to expire after 7 years. Fine. Recopy all the existing objects here and there. See, this is fine until this particular point. You're using compliance retention mode. Basically, this mode is very strict. No one, even the root user, cannot override the lock until the retention period expires. That is what we need. That is legally, we need that particular thing to work over here. Compliance retention mode is absolutely perfect, but we are still using the recopying thing to copy all the existing objects to bring the existing data into compliance. We don't need to recopy all the existing objects like this, right? So C is not going to make sense for me, and D is left, so that is the correct option. And here it says that object lock with compliance mode, absolutely perfect. Then it is saying that use S3 batch operations to bring the existing data into compliance. So S3 batch operation is, it's a service that you know lets you perform this large scale operations like applying object lock to the existing objects in the S3. So you don't have to recopy anything. I was looking for this batch operations. That's why I was saying that the C will not work in this case. It will not need all that additional overhead. I mean, it will automate the process of applying this object lock, this policy, this strict legal requirement on all the existing objects and as well as the new objects, right? So that's absolutely perfect. So D is making sense for me. So I'm going to go with D. Question number 129, guys. So question number 129 says that a company has you know, a stateless web application that runs on AWS Lambda functions that are invoked by Amazon API Gateway. The company wants to deploy the application across multiple AWS regions to provide regional failover capabilities. What should a solutions architect do to route traffic to multiple regions? Now, the company has a stateless web application running on AWS Lambda functions, right? And they are invoked by a trigger, which is the gateway, API gateway. So they want to deploy the application across multiple AWS regions and they want to have this failover capabilities. So the goal is to route traffic to multiple regions so that if one region goes down, traffic can fail over to another region. Okay, so let's go through the option. Option number A says that create Amazon Route 53 health checks for each region and use an active failover configuration. So um, Amazon Route 53, it's a DNS service of AWS and it's great for routing traffic based on the health checks, latency, geolocation, whatever you need. Now, health checks ensure that the traffic is routed to the healthy regions. Yeah, you can do that. There is, Route 53 can monitor the, the health of your application, and which is in each region, right? It's region wise. So that will help you to route the traffic to the healthy guys. Active failover. This means that traffic is distributed across multiple regions, and if one region fails, traffic is routed to the others. It's absolutely making sense to me, and I would think that this is a very strong contender for the correct option. So I will stick to A for now. Let's move on to the, next option. Option B says that create a, an Amazon CloudFront distribution with an origin for each region. Use CloudFront health checks to route the traffic. So CloudFront is a CDN, and its main feature is that caching, which caches content at edge location to reduce the latency. And it is good for the static content, but it is not designed for this active failover across the regions. It's not designed for that, right? So I'm not going to go with CloudFront. CloudFront has a separate, use case altogether. So I'm not going to go with this particular option. Option number C, we'll check. C says that create a transit gateway, attach the transit gateway to API gateway endpoint. Hold on. Transit gateway. No, transit gateway is a service that is used to connect multiple VPCs as well as the on-premises networks, right? I mean, it doesn't work over here. It's designed for your network connectivity, not for your global traffic routing and whatnot, right? And it doesn't provide health checks or automatic failover, whatever this particular question is asking. So transit gateway is out of the question altogether over here. Create an application load balancer in the primary region. Set the target group to point to the API gateway endpoint host names in each region. I mean, ALB is designed for load balancing in a single region, not for cross-region failover, right? And it doesn't provide this health checks or failover capabilities across the regions, right? I mean, this doesn't meet that particular requirement of regional failover. So I'm not going to go with D. So correct option in my opinion is A. So we're going to stick with that. Okay. Next is question number 130. And this particular question says that company has two VPCs named management and production. The management VPC uses VPNs through a customer gateway to connect to a single device in the data center. The production VPC uses a virtual private gateway with two attached AWS Direct Connect connections. The management and production VPCs both use a single VPC peering connection to allow communication between the applications. So what should a solutions architect do to mitigate any single point of failure in this particular architecture? So what we are looking here is basically removing the single points of failure in the current setup and ensure that there is high availability. Basically, that's the particular point. We have to, mitigate this single point of failure in the architecture and have high availability. That's what it is asking. So option number A says that um, add a set of VPNs between the management and the production VPCs. So the management VPC, right? If you see the management VPC already connects to the data center via VPN. So basically, that is what it is asked. The company has two VPC management and production. The management VPC uses a VPN through a customer gateway to connect to a single device in the data center. So it is already connecting to a data center via VPN, and the production VPC connects via direct connect. So adding VPNs between the VPCs doesn't address the single point of failure that we need. You might get confused over here. VPNs are not built for this particular purpose, right? So I'm not going to go with A over here. B says that add a second virtual private gateway and attach it to the management VPC. So add a second virtual private gateway. So private gateway is used for VPN connections or direct connect. If you attach it to a management VPC, this would provide a second connection point for the management VPC. See, the management VPC currently uses a customer gateway on-premises device for its VPN connection, right? So adding a virtual private gateway to the management VPCs does not address what we are trying to solve over here. And this doesn't add the redundancy to the on-premises side of the VPN connection. So I'm not going to go with B as well. Option number C says that add a second set of VPNs to the management VPC from a second customer gateway device. Now, add a second set of VPNs. This would create a second VPN connection from the management VPC to the data center, right? So the management VPC currently relies on a single customer gateway device, right? That's what we discussed in the previous option also. It's a single point of failure. That's what we want to reduce, or we want to, address. Now, adding a second customer gateway device and a second set of VPNs remove this single point of failure problem. So C is a correct option in my opinion. So this ensures, what does it ensure? That if one VPN connection or customer gateway fails, there is another one. So this is a very good option in my opinion. D says that add a second VPC peering connection between the management VPC and the production VPC. I mean, it's related to the data center. It's not between the management VPC or the production VPC. It doesn't make any sense to add a second VPC peering connection between the management VPC and the production VPC. So I'm not going to go with D as well. So correct option is C. It's a little bit confusing, and just keep practicing, and you would get all the correct intuition for the questions. Okay, guys. So let's move on to the next question. Okay, guys, so let us see question number 131. It says a company runs its application on an Oracle database. The company plans to quickly migrate to AWS because of limited resources for the database, backup administration, and data center maintenance. The application uses third-party database features that require privileged access. Which solution will help the company migrate the database to AWS most cost effectively? So basically, what are the key points asked in the question, right? Currently, they are on Oracle DB, ODB, we can say. I mean, just for short answer, whatever. They want a quick migration to AWS, and they have limited resources for database management. So the plan is to use managed services as much as possible on AWS. Okay, and they need some required privileged access, right? Cost effective is just, part of every question, so whatever. So, um, basically, if you see option number A says that migrate the database to Amazon RDS for Oracle, replace third-party features with cloud services. Now, this sounds really good, right? But replacing third-party features with cloud services means rewriting parts of the application. That is not a quick solution, right? And it can be very expensive. So I'm not going to go with this particular option. Option number B says that migrate the database to RDS custom for Oracle, customize the database settings to support the third-party features. Now, this is absolutely perfect because RDS custom gives you like the best of both worlds, right? It's a managed service, right? So AWS handles everything. You get privileged access, that is part of the question, right? So third-party features, whatever you have, it works seamlessly, and it's faster than rewriting the whole app so that RDS for Oracle will support. So we can easily go with RDS custom for Oracle, which is a better option, right? And it is cost effective as well as the overhead is really, really less. So I'm going to go with option number B. Option number C says that you know, migrate the database to an Amazon EC2 AMI, Amazon machine image for Oracle. This is just plain idiotic because you want to use managed services. At least this option had the option for to use Amazon RDS for Oracle, but Amazon EC2, I'm not going to consider it at all. Migrate the database to Amazon RDS for PostgreSQL by rewriting the application code. You don't want to rewrite the application code and that to PostgreSQL. That doesn't make any sense. You want to stay in Oracle. So Oracle, AWS, sorry, RDS custom is the way to go. So I'm not going to go with D as well. Question number 132. So a company has a three-tier web application that is in a single server. The company wants to migrate the application to AWS cloud. The company also wants the application to align with the AWS well-architected framework and to be consistent. Sorry, I forgot to mark it. And to be consistent with AWS recommended best practices for security, scalability, and resiliency. Which combinations of solutions will meet these requirements? We have to choose three options. That's a big three. I mean, anyways, so let's you know decode or analyze the question first of all. So it's a three tier web application, web tier, application tier, and database tier. It's currently running on a single server. So we have a single point of failure. So that is one thing. So we have to migrate it to AWS with the well architected framework, keeping in mind the well architected framework, which has to be, secure, I mean, security, then scalability and resiliency, right? Those are the best practices. So we have to examine each option and find out three options which are the best. So option number A says that create a VPC across two availability zones with the application existing architecture. Host the application with existing architecture on Amazon EC2 instance in a private subnet in each availability zone with EC2 auto scaling groups. Secure the EC2 instance with security groups and network access control lists, which is ACLs. Okay, this is the last. Okay, secure the EC2 instance with security groups and network access control list, network ACL. So basically, what are you doing over here is you are having a multi-AZ setup, right? It sounds good. You are doing auto scaling, right? EC2 auto scaling groups you are using, and you are also using security groups. But there is a but over here, and the but is it says existing architecture means that all the three tiers are still bundled together. It's like a monolith application. That defeats the purpose of AWS best practices that we want to achieve over here. So we don't want to go with that approach. We have to, better that approach. We have to be better, right? In the words of God of War, Kratos, be better. So we're not going to go with A due to that reason. Option number B. Set up security groups and network access control list ACLs to control access to the database layer. Set up a single Amazon RDS database in a private subnet. Security is fine because you're setting up the RDS database in a private subnet, but a single RDS instance means no multi-AZ. I mean, what does well architected framework screams? You have to have resiliency. If this setup fails, if the AZ goes down, you don't have to panic. There should be another standby, and here we have nothing. So it's too risky. We're not going to go with this single RDS database in a private subnet. So we're not going to go with B as well. C says that. So we get left with four options and we have to choose three. It's an easy thing. Let's go with it, right? C says that create a VPC across two availability zones, refactor the application to host the web tier, application tier, and database tier, host each tier in its own private subnet with auto scaling groups for the web tier and the apps, application tier. Absolutely perfect. Why? Because we have separate tiers, multi-AZ we have, right? Because the two availability zones we are taking, and resiliency we are having, right? Auto scaling groups we have for the web and the app application tiers, which is scalable, right? That is also checked, and it's like it's a hits it out of the ground. It's like a six in cricket. For those of you who don't know cricket, it's like a home run in baseball, right? or a hat trick in football, whatever you want to just relate. You know, I'm just blabbering at this point, but whatever. So everything is met over here. So AC is a best solution in my case. So we got our first option. Considering D says that use single Amazon RDS database. C, again, single RDS database, right? So we don't have to even read it further because we don't want a single point of failure for databases as well, right? We have to consider everything. So we are left with two more options, which is E and F. So obviously they are the correct options, but let's just give them a chance and see what is happening. Elastic load balancer in front of the web tier. Control access by using security groups containing references to each layer security groups. Absolutely perfect because Elastic Load Balancer, it's for scalability, resiliency. I mean, absolutely good. Security groups referencing each groups, right? You can have some inbound or outbound rules, whatever and whatnot, and your load balancer will help you to spread the traffic across the instances, right? So it's very good, and I think E is also a better solution. F says that use an Amazon RDS database multi-AZ cluster deployment in private subnets, allow database access only from application tier security groups. That's what I told, right? Um, you have this controlled access over here. I mean, you are doing what? Allow database access only from the application tier security group. So you are creating rules over here, which will allow certain traffic from certain security groups, and that is what we need over here, right? So it's a very absolutely good solution. So the correct option, in my opinion, is C, E, and F. Question number 133. So we move on to the next question. A company is migrating its applications and databases to the AWS cloud. The company will use ECS, Direct Connect, and RDS. Which activities will be managed by the company's operational team? It says choose three. We have to choose three. This just takes a lot of time. But anyways, we also have to consider these type of questions because you will not always get the single choice answers, right? And that's what it is. So what do we need over here? We need ECS, we need Direct Connect, and we need RDS. So it's about shared responsibility, right? It says which activities will be managed by the company's operational team. So basically, AWS, what it will manage, and you as a company or the operational team, your job is to choose the three things the company must manage themselves. That's why it's asking for three options, right? So let's see option number A says that management of the Amazon RDS infrastructure layer, operating system and platforms. RDS is a managed service, right? So AWS manages everything. So basically, you don't have to do anything. So A is not our option. B says that creation of an Amazon RDS DB instance and configuring the scheduled maintenance window. Now, you as a company or an operational team, creates the RDS DB instance. It's your job. So you are responsible for choosing the configuration, scheduling your maintenance window, backups, snapshots, and whatnot. So this is absolutely your job. So B is the correct option. So we have to go with two more. So let's move on. C says that configuration of additional software components on Amazon ECS for monitoring, patch management, log management, and host intrusion detection. Now, ECS, manages your containers, right? But whatever is inside those containers, it's your responsibility. Whatever software you're using, whatever libraries you're using, security, monitoring, logging, patching, it's all up to you, right? It's like uh, ECS is a car, right? And you are driving it. You are inside that particular car, right? You are responsible for its fuel, its cleaning, its maintenance, and whatnot. Oh, I just gave an analogy, I think. It was good. So, yeah, C is also the correct option. So, B and C, we got two of the options. Now, out of the three options, we have to choose one. Installation of patches for all minor and major database versions. See, database versions are managed by Amazon RDS, so you don't have to worry about all those things. Ensure the physical security. You are not a security guard at that particular data center where the database is hosted, right? So you don't have to worry about that as well. And that is leaves us with one option, which is F, which is correct option. Encryption of data is obviously your job, right? It's very easy question. It's been a while since we faced this, baby question. So I'm just gonna mark it with baby question category. It was very easy, and yeah, we should have some relaxing and baby question. So one more thing, if it's a managed service infrastructure like RDS, uh, you know, hardware OS, AWS handles it, but everything else like security, your containers, configurations, data encryption, that's your job. So keep that in mind, and you will be able to, answer these questions without any issues. Okay, so a company runs a Java-based job on an Amazon EC2 instance. The job runs every hour and takes 10 seconds to run. The job runs on a scheduled interval and consumes 1 GB of memory. The CPU utilization of the instance is low except for short surges during which the job uses the maximum CPU available. The company wants to optimize the cost to run the job. Which solution will meet these requirements? So, Um, Java-based job, right? It is running every hour, right? Duration is 10 seconds, right? And what else we have? We have 1 GB of memory it is consuming. It has a peak CPU usage, but the utilization is generally low. So our goal is to minimize the cost while still making sure that the job runs smoothly on the scheduled, I mean, based on the schedule, right? Now let's see which option is going to meet the requirements. And let's see. So option number A says that use AWS uh, app to container A2C to containerize the job, run the job as an elastic container service ECS task um, on Fargate with zero point 0.5 virtual CPUs and 1 GB of memory. So why do we want to get that? I mean, we don't want to use all this app to container. It's weird. Then you have to use ECS and AWS Fargate, zero point 0.5 virtual SIP. It's a lot of configuration. I don't like this. I'm not going to go with it. It's just too complicated and it's not that much cost optimized. Also, you have to use a lot of services. Anyways, option number B, I can see that it's a very good option. It says that copy the code into an AWS Lambda function that has 1 GB of memory, create an Amazon Event Bridge scheduled rule to run the code each hour. Absolutely perfect. See, Lambda is serverless. You pay for the compute time you consume, and the job takes only 10 seconds to run. So Lambda is perfect for these short term jobs, which is under 15 minutes. You don't want to provision a container or a Docker container for a 10-second job. That doesn't make any sense. So I'm going to say that B is the correct option in my opinion. And perfect for this short burst job like 10-second job, and it's a very simple step, and you can use Event Bridge for this simple scheduling as well. So it's highly cost effective and it's straightforward. So B is the correct option. C says that use app to container A2C to containerize the job, install the container in an existing. Okay, this just doesn't make any sense. This was making some sense that you might be considering it, but AMI, no, that's not gonna work. D says that configure the existing schedule to stop the EC2 instance at the completion of the job and restart the EC2 instance when the next job. What? No. Why do I have to do it manually when I can automate it using Event Bridge and Lambda, right? So, so whenever it comes to optimizing for costs, right, on AWS, it should always, you should look for any serverless solution. And if it is a short-term job, it's always Lambda, guys. If it's a short-term job within 15 minutes, they will obviously specify the time. They will not make it more confusing by saying that I don't know about the time, right? So if it's under 15 minutes, job is very short, just go for Lambda, guys. Anyways, let's go to the next question. A company wants to implement a backup strategy for Amazon EC2 data and multiple Amazon S3 buckets. Because of the regulatory requirements, the company must retain backup files for a specific period time. The company must not alter the files for a duration of the retention period. Guys, we just I think solved similar kind of question couple of questions back. It's obviously you have to use the governance mode, sorry, the compliance mode with the vault lock or object lock. Wherever you see this kind of a question, just go with the compliance mode. And I can see that D has that particular option. So this is the correct option. But if you want to just go through the options, we'll just go through it. But anyways, this is just a straightforward baby question, right? Whenever it comes that there is a legal requirement, there is a compliance requirement that there should be some rule that has to be applied on some data that cannot be deleted or something like that, you should always go with compliance mode on object or vault lock, right? Anyways, option number is that use AWS backup to create a backup and that has a vault lock in governance mode, right? Create the required backup plan. See, vault lock, governance mode sound secure, but authorized users like the admins or the root users can still do all the whatever they want. So obviously governance mode is a no-go. B says that data lifecycle manager, I mean, to create the required automated snapshot policy. But see, lifecycle manager is for a different purpose altogether. It doesn't guarantee immutability or compliance, right? And so I'm not going to go with the lifecycle manager. S3 file, okay, file gateway. Why? I don't even have to explain this to you guys. It's like whatever. So let's go to the next question. Question number 136. Company has resources across multiple AWS regions and accounts. A newly hired solutions architect discovers a previous employee did not provide details about the resources inventory. The solutions architect needs to build and map the relationship details of the various workloads across all accounts. Which solution will meet this requirement is the most operationally efficient way? I don't know. Why are these employees like this? Some employees deleting the database and some employees not recording or giving the KT to the new employee. It's just not making sense, guys. But our job is to solve the question, not discuss about this. So let's quickly decode the question. So what it's asking is company has resources scattered across multiple AWS regions and accounts, right? There is no proper documentation, no wiki. It's a big headache, and there is a guy who wants to map as a solutions architect needs to build and map the relationship details of all the workloads, right? So we have to efficiently do that. Okay, so option number A, systems manager inventory to generate a map view from the detailed view report. Systems manager, what it is. So systems manager inventory, it tracks the configuration and software data, but it doesn't automatically create architectural diagrams, right? So what does it say? They don't provide details about the resource inventory. The solution architect needs to build and map the relationship details of the various workloads across all the accounts. So it will keep the track of the configuration, but there is no diagram or relationships between the resources. It will not show you that. So it is just like an inventory system. Like, okay, you have this much of this, you have this much of that. That's it. It generates the detailed inventory lists, but not the relationship mapping that you need over here, right? So we are not going to use this basic stuff. We need some better, you know, tool or service for this particular purpose. B says that use step functions to collect workload details, build architectural diagrams of the workloads manually. See, we need to avoid this thing, manual step, right? Now, step functions, just to talk about it, it's used to orchestrate. Sorry, I hope that I got that word right. I have trouble pronouncing some of the words. So orchestrating workflows, that's where the step functions are absolute brilliant. But for managing inventory or relationship mapping, it's not a very good solution. Option number C, use workload discovery on AWS to generate architectural diagrams of the workloads. Yes, this is absolutely perfect. Why? So workload discovery is specifically built to discover resources across multiple accounts and regions. So what are the advantages of that? It automatically visualizes workloads, generates your diagrams, architectural diagrams and whatnot, and clearly shows how resources connect and depend on each other. So you don't have to manually do anything. It's like automating everything that you have. So I think, in my opinion, workload discovery is the correct option. So I'm gonna go with C. D says X-ray. X-ray has a different purpose altogether, like tracing requests or debugging, right? It's like you send the trace within the application for monitoring its performance, or debugging, or if there is an issue you can track, right? But multi-account infrastructure mapping, it is not a very good solution. It's actually, you cannot use it. So not going to go with X-ray. Let's move on to the next question. Question number 137. Company uses AWS organizations. The company wants to operate some of its AWS accounts with different budgets. The company wants to receive alerts and automatically prevent provisioning of additional resources on AWS account when the allocated budget threshold is met during a specific period. Which combinations of solutions will meet these requirements? And we have to choose three. Okay, we have a lot of questions now today with this, where we have to choose three, but whatever, we have to do it. So first of all, company uses this AWS organizations. It's a fantastic tool to manage your accounts. So they want different budgets for different AWS accounts, right? They want different budgets. They need alerts when budgets are reached. And what they need is, they want to prevent new resources from being provisioned after they cross the threshold of the budget that they had set, right? So we have to choose three solutions. We have to choose three options for the solution. Option number A, AWS budgets to create a budget, set the budget amount under the cost and usage report section of the required AWS accounts. What? AWS, hey, one second. What did I read just now? Set the budget amount under cost and usage reports section of required AWS accounts. AWS budgets configured under cost and usage reports. That's not how AWS budget works, first of all. I just got confused over there. You will also get confused, right? So budgets aren't set via the cost and usage reports. They are set directly in AWS budgets, right? You cannot just justify this particular option because it's wrong. That's absolutely wrong. There's a separate AWS budget. You go there and then set the budget. You don't do it, like this. Option number B says that use AWS budgets to create a budget. Set the budget amount under the billing dashboards of the required AWS account. Yes, yes. This is exactly the place where you set up the budgets and you manage the alerts, right? What? Nice. Let's go on to the next question. Sorry, not next question. Option. Create an IAM user for the AWS budgets to run budget action with the required permission. IAM user means using long-term credentials tied to a user account, and basically it's not ideal for automated AWS services, right? And it's just we should not use IAM users, but instead we should use roles in this particular use case, right? So I'm not going to go with particular option C. Option number D, I can see that the same option with the IAM role thing. So that is what we need basically. AWS always prefers IAM roles over IAM users for automation and security, especially when an end user is not involved over here. You want to automatically do something or automatically make a service do something, you have to assign a role to that particular thing, right? So, and role, you don't have to share the credentials, it provides temporary credentials. It's, perfectly suitable for AWS services. Okay, it's a very easy thing to understand. So, not going to go very much deep into that. Option number E says that create an alert to notify the company when each account meets its budget threshold. Add a budget action that selects the IAM identity created with the appropriate config rule to prevent provisioning of additional resources. So basically, what it is asking is config rules, right? But config rules focus on compliance checks, right? And it also helps in evaluating the configurations. They don't prevent like provisioning of EC2 instance or something like that. So config rules, it won't automatically block a new resource provisioning, right? I mean, based on the budget threshold, you want to block someone, you cannot use config rules for that. They have a different purpose altogether. It focuses on compliance checks. So we are not going to go with E over here. So we are left with only F, and that is the correct option, F. But let's go through the option. F says that add an alert to notify the company when each account meets its budget threshold. Add a budget action that selects the IAM identity created with the appropriate service SCP, service control policy, to prevent provisioning of additional resources. Absolutely perfect. SCPs are perfect for enforcing policies at the organization's level that directly prevent the resource provisioning. So basically, you hit the budget limits, the SCP kicks in, I mean, automatically, and it stops the users from creating new resources. That is what we need over here. So SCP and organizations, AWS organizations, have a brilliant relationship, right? So whenever you have to automatically enforce something across multiple accounts, remember you have your three best friends: budgets, IAM roles, and SCPs. So they work together to make your budgeting life easier, right? And whenever it just comes to, prevent something or enforcing something at just the organization's level, service control policy, SCPs are your bestest friend, right? The best friend out of your best friends. Any case, let's move on to the next question, question number 138. It says that a company runs applications on Amazon EC2 instances in one AWS region. The company wants to back up the EC2 instances to a second region. The company also wants to provision EC2 resources in the second region and manage the EC2 instances centrally from one AWS account. Which solution will meet this requirement? So, what are we looking at over here? Company has EC2 instances in one AWS region, so one region, right? And they want backup in a second region for disaster recovery purposes, right? They also want the ability to quickly provision the EC2 instances in that second region if needed. If needed, remember this word, if needed. They must be cost effective. So, what are the options that we are looking over here? A says that create a DR plan that has similar number of EC2 instances in the second region, configure data replication. So what you are doing, you are having a full set of instances ready in the second region. It's very expensive. It's like an active thing you are doing. Also, you are essentially doubling your EC2 instance costs, right? You are not cost effective in this particular option. So I'm not going to go with A. right? Option number B says that create point-in-time EBS snapshots of EC2 instances, copy the snapshot to the second region periodically. So EBS snapshots are way cheaper than running full instances concurrently or constantly, right? So periodic copies to another region means you are ready for disaster recovery, basically without paying full compute costs until necessary. That's why I said the very important word over here to note is if needed, right? You don't want to keep an active setup ready. You only want to make it active when it is needed. So in this case, B checks all the boxes. It's cost effective, it's flexible, and it's absolutely good. I didn't find another word for that. Option number C says that create a backup plan by using AWS backup, configure cross-region backup to the second region for EC2 instances. Hmm. Now that I read option number C, no, I'm not gonna go with that. Um, because it's not that cheap. I got a little bit confused over here because AWS backup simplifies your cross-region backups for EC2, and it's very easy to manage it centrally, right? Because AWS backup you can manage it like very easily, right? It's an automated solution, but introduces slight overhead costs compared to your raw EBS snapshots that we saw in option number B, which is very cost effective and reliable. It's very good in terms of efficiency, but I think, in my opinion, that EBS snapshots are still cheaper. So I'm going to stick with my option number B. I just saw this AWS backup and I saw that, you know what, it might be a good solution, but let's not go with that. Let's stick with option number B. So D says that deploy a similar number of EC2 instances in the second region. We don't want to do that, right? We want to avoid that. We only want to deploy it when needed. Okay, so let's move on to the next question. Question number 139. So a company that uses AWS is building an application to transfer data to product manufacturer. The company has its own identity provider IDP. The company wants the IDP to authenticate application users while users use the application to transfer the data. The company must use application statement to AS2 protocol. Which solution will meet these requirements? So option, okay, let's before going to the options, let's understand the question. Company needs data transfer capability to a product manufacturer, right? They must use AS2 protocol, right? This is a very important thing to understand. AS2 protocol, I forgot to mark it. And it has its own identity provider IDP, so authentication will be done using this particular IDP that it has, right? And that's the key points. So let's move through the options now. Option number A says that use AWS data sync to transfer the data, create an AWS Lambda function for IDP authentication. Now, data sync is great for syncing data between storage, but data sync does not support the AS2 protocol. That's why I told you you have to be very careful about certain points in the question, in this case, the AS2 protocol. Lambda can authenticate users, but the lack of AS2 does not specify the use of Lambda over here. So A, I'm not going to go with that. B says that use Amazon App flows to transfer the data. Create an ECS task for IDP authentication. Now, Appflow excels at SaaS integration, right? But same thing, it's not for AS2, right? So I'm not going to go with B as well. C says that use AWS transfer family to transfer the data, create an AWS Lambda function for IDP authentication. This is fine. We already discussed Lambda can do the IDP authentication. Transfer family, yes, it's designed explicitly for secure transfers and supports the AS2 protocol. It's perfect. This is exactly what we need, right? And Lambda function will take care of the IDP authentication. You can write your custom logic there. So that makes sense. So C is the correct option. And we are left with D over here, which says use AWS storage gateway to transfer the data, create an Amazon Cognito. Okay. See, storage gateway is for hybrid storage scenarios. It's not intended for, AS2 transfers, AS2 transfers. Now, Cognito identity pools handle your IDP, but AS2 support, it's not going to work with that as well. So, not going to go with D as well. Next question, question number 140. It's a lot of questions, man. So, what we are doing over here basically is, let's take a huge breath and then solve the question. A solutions architect is designing a REST API and Amazon API gateway for a cache payback service. The application requires 1 GB of memory and 2 GB of storage for its computation resources. The application will require the data is in a relational format. Um, which additional combination of AWS services will meet these requirements with the least administrative effort? So what it does, what does the question mean over here is basically you are building a REST API with API gateway. App requires 1 GB of memory and 2 GB of storage. So, and the data must be stored in SQL, I mean in a relational format. So in any SQL database will be using, and we need to have the least. It's a baby question, guys. Right? It's already given in the question. Just have to, see the options. Amazon EC2, first of all. EC2 gives you maximum flexibility, but you have to do a lot of, administration or your minimal effort that you need, least administrative effort, that will not work. So EC2, not going to go with that. B says that AWS Lambda. Lambda is serverless, so you don't have to handle anything. Short-lived REST API. I mean, it easily integrates with your API gateway and it meets your 1 GB memory requirement. So it's absolutely perfect in my opinion. So B is, I will go, it's a huge thumbs up for that. C says that Amazon RDS, you want to use SQL, you use Amazon RDS, right? You can use MySQL, PostgreSQL, anything, and AWS will handle all of your patching, backups, and your high availability, whatever and whatnot. So your admin effort is also reduced. DynamoDB, SQL we are going to use. We are not going to use any NoSQL database, so DynamoDB is not going to work. Elastic Kubernetes service, good option, powerful container management service, right? But you need to have a DevOps person to handle all this stuff, and it requires some administrative effort, which we do not want. So I'm not gonna go with E as well. So yeah, guys, let's move on to the next question. Okay, so let us see question number 141. So it says a company uses AWS organization to run workloads within multiple AWS accounts. A tagging policy adds department tags to AWS resources. When the company creates tags, an accounting team needs to determine spending on Amazon EC2 consumption. The accounting team must determine which departments are responsible for the costs regardless of the AWS account. The accounting team has access to AWS Cost Explorer for all AWS accounts within the organization and needs to access all reports from Cost Explorer, which solution meet the requirements. So basically, they are using AWS organizations, so keep that in mind. They are already tagging resources, right, with a department tag through a tagging policy. So the accounting team wants to track the EC2 spending by department. That is what the question is asking. Right. Now let's go through the options, which will be the most efficient solution. A says that from the organization management account billing console, activate a user-defined cost allocation tag named department, create one cost report in Cost Explorer, grouping by tag name and filter by EC2. Absolutely perfect. Why? Because tags created by tagging policies, right? Like custom tags you've defined, that you have created, they are considered user-defined cost allocation tags. So you're also activating it from the organization management account. This is the key point you have to, notice. So what it does, it allows the accounting team to see easy to spending across every linked account. Okay. So whenever there is something like related to this kind of a question, when it comes to user defined tags, you define the custom tags, right? Here you are creating a user defined tag, cost allocation tag, right? And there are also predefined AWS tags that is different. Okay. And you're using organizations, AWS organization. So you have an organization management account, which is efficient management for the whole organization, right? So I hope that is making sense. Now going to option number B, we are also going to consider other options as well. It says that from the organization management account billing console, activate an AWS defined cost allocation tag name department, create one cost report in Cost Explorer grouping by tag name and filter. What is this option same? Okay, activate an AWS defined, right? Okay, that's the difference. As I just explained to you, here, I just got confused because it was being similar, but the catch here is the phrase AWS defined cost allocation tag, right? So AWS defined tags are automatically created by AWS services. For example, like AWS colon created by, right? Like this particular thing. So here the company defined a custom department tag using a tagging policy, meaning it's user defined, not AWS defined, right? So AWS defined are pre-made labels, right? They are provided by AWS and it's like a pre-made stamps that you can already use. But here we need custom tags for this particular scenario. So B is not going to cut it. So C says that from the organization member account billing console, activate a user-defined cost allocation tag name department, create one cost report in Cost Explorer grouping by tag name and filter by EC2. So here also, this also is a similar kind of an option. You can get confused, but here the main point to notice is the member account. Okay. Now, the idea of using a user-defined tag is correct, right? Doing it from the member account billing console is inefficient. Why? Because it would only apply to a single member account. But here you are already using organization, right? You don't have to worry about, uh, you know, a single member account individually. So I'm not going to go with C for that particular purpose. D says that from the organization's member account billing console, activate an AWS defined cost allocation tag named department, create one cost report. So AWS defined, right? So, and also member account, both are not needed over here. So D is also not needed. Question number 142, it says that a company wants to securely exchange data between its SaaS application, Salesforce account, and um, Amazon S3. The company must encrypt the data at rest by using KMS key management service, customer managed keys, CMKs. The company must also encrypt the data in transit. Company has enabled API access for Salesforce account. So what we are trying to solve here? Basically, you have a company using Salesforce, which is a SaaS application, right? And they need to securely move data into an S3 bucket. They need encryption at rest. It seems like eat at rest, but I just wanted to say encryption at rest, right? And they need encryption as transit as well. So encryption at transit, right? So company must encrypt the data at rest by using KMS, customer managed key. Company also encrypt the data in transit. This is a scenario. Now, data is moving from Salesforce to AWS. Security is the main thing that we need to see over here. And we also need to be keeping in mind that it should not be overly complicated, right? That's the crux of every question. So A says that create AWS Lambda function to transfer the data securely from Salesforce to Amazon S3. Now, Lambda is a powerful and flexible serverless service, right? But using Lambda here would mean that you are writing your own code to manage authentication, API calls to Salesforce, handling encryption in transit, and manually handling all of the stuff, which I just discussed that we have to make it less complicated. So, less complicated. We are not going to go with that. We already have a better solution than this. Option number B says that create an AWS step functions overflow. Define the task to transfer the data securely from Salesforce to S3. So, as not Salesforce, step functions are for orchestration tools, right? So, this is not going to cut it. We don't need any stepwise orchestration over here. So, B is also not going to cut it. C says that create an Amazon app flows to transfer the data securely from Salesforce to S3. Correct. Why? So App is literally built for this exact scenario. Why? Because first of all, it's a fully managed AWS integration service that securely transfers data between SaaS applications like Salesforce over here and AWS services like S3. It has built-in encryption and data, obviously it needs encryption, for data at rest, right? So it is already has that built-in capability as well as data in transit, right? Both of these are there in Appflow, right? And obviously we're going to use your KMS CM case, right? That it was asked in the question. So Appflow will handle all the authentication, APIs, encryption, and even other stuffs as well. I don't remember all of the stuffs, but it will handle most of the things for you. So Appflow is like a bridge, right? It's like a secure bridge and between your SaaS application and your S3, and you're securely transferring the data. So one very good tip I would like to tell you in this question is that if in the exam it mentions SaaS integrations like Salesforce, Slack, ServiceNow, whatnot, right? Airflow is typically should be the answer, in my opinion. So you don't have to get confused with all other options. You should probably consider Airflow in this type of SaaS integration question. So SaaS, right? So this is also doesn't make any sense. Custom connector for Salesforce. I don't want any connectors. I whatever. Company is developing a mobile game app in a single AWS region. The app runs on multiple EC2 instances in an auto scaling group. The company stores the app data in Amazon DynamoDB. The app communicates by using TCP traffic and UDP traffic between the users and the service. Application will be used globally. The company wants to ensure the lowest possible latency for all users. Which solution will meet this requirements? So, what does the question says? Single AWS region. I forgot to mark it out, right? Communication using TCP and UDP. So TCP and UDP, very important to notice because I can see some of the options having, global accelerator integration or an NLB. So basically, this is very important to notice that communication uses TCP and UDP. Lowest latency, app data stored in DynamoDB. Those are some things you can notice on the way, but yeah, so these are the important points. Let's see the options. Global accelerator. Option number A says that global accelerator to create an accelerator. Create ALB behind accelerator endpoint that uses global accelerator integration and listening on the TCP and UDP ports. Update the ASG to register instances on the ALB. Absolutely incorrect. Why? ALBs, as a you already know, we have solved like a lot of questions. HTTP, HTTPS traffic, please go with ALB, like layer 7 traffic only. They don't handle this UDP traffic. Our gaming app explicitly needs both TCP and UDP traffic to work, right? So not going to go with A. B, global accelerator, create the accelerator NLB behind. You know what? This is the correct option. Why? Because NLBs handle your layer 4 protocols like your TCP and UDP traffic, and you combine it with global accelerator. I mean, that's just the backbone of your gaming application in this particular scene. It will significantly reduce latency and it's fast, I would say. Speed is good, whatever and whatnot, right? So, best combination in this scenario. So, I've told you numerous times that global accelerator is specifically designed to reduce latency for all the users, for all the global users. So what it does, it routes traffic efficiently through AWS's private global networks, right? And if you pair it with your NLB, it's ideal for this particular scenarios where you need to handle all the speed, all this layer 4 traffic. Create and CloudFront. You see, these two options I'm going to completely reject because I see CloudFront over here. CloudFront is a CDN, it's for static content. It's nowhere useful in this particular scenario. You know what? Let's mark this question as a baby question. It's very easy. Question number 144. Okay. Now, it says that a company has an application that processes customer orders. The company hosts the application on an EC2 instance that saves the orders to an Amazon Aurora database. Occasionally, when traffic is high, the workload does not process orders fast enough. What should a solutions architect do to write the orders reliably to database as quickly as possible? So reliability is critical over here. We don't need any lost orders. Orders need to get into Aurora quickly and efficiently. Second point. Third point, we need to handle occasionally high traffic. So scaling is very essential. Scaling, right? So let's see all the options and see which is the correct option. Option number A says that increase the instance size of EC2 instance when traffic is high, write orders to SNS, subscribe the database endpoint to SNS topic. You can't subscribe Aurora databases directly to SNS. SNS is mainly used for notifications, right? Like emails, SMS, HTTP endpoints, Lambda functions, all these stuffs. You can't push orders directly into Aurora using SNS. Also, increasing the instance size of the EC2 instance when the traffic is high, manually, I don't see it as a very good response. Option number B says that write orders to an Amazon SQS queue, use instances in an auto scaling group behind an application load balancer to read from the SQS queue and process orders into the database. Now, this is absolutely perfect. Why? You're using SQS, and in this scenario, SQS ensures your reliability, you know, ordered storage of requests. Now, even if your database is temporarily slow, your EC2 instances can't keep up, it will act as a buffer over there, right? They can read from the queue at their own pace, smoothly handling all the traffic spikes, right? We all know that SQS is a queue. I have discussed this in a very detailed manner in my SQS video, so you can go and have a look at it. Okay, I hope that is making sense. So SNS, option number C says SNS, so I'm going to reject that. Option number D says that SQS queue with when the EC2 instance reaches CPU threshold limits, use scheduled scaling of EC2 instances. See, scheduled scaling we don't need because we are not sure about the traffic spikes and whatnot. So I'm not going to go with D as well, right? So let's move on to the next question. Next question is question number 145. It says that an IoT company is releasing a mattress that has sensors to collect data about a user's sleep. The sensors will send the data to Amazon S3 bucket. The sensors collect approximately 2 MB of data every night for each mattress. Company must process and summarize the data for each mattress. The results need to be available as soon as possible. Data processing will require 1 GB of memory and will finish within 30 seconds. Oh, that's that's just amazing. This is a newborn baby question. Why? Finishing between 30 seconds, 1 GB of memory, process and summarize data for each mattress. Sensors collect 2 MB of data every night for each whatever, whatnot. But the main sellout point of using Lambda functions over here is this 1 GB of memory and finishing within 30 seconds. The results need to be available as soon as possible. That is also one of the things. The Lambda function must be triggered in a very fast manner. And Lambda functions are very fast, lightweight, and serverless. So absolutely perfect over here. So I'm going to go with use a Lambda with a Python script. I can easily see that. Glue is an ETL tool, not going to use over here. EMR is just out of the question. Glue is, as I told you, an ETL tool. So not going to be useful over here. Next question. Question number 146. It says that a company hosts an online shopping application that stores all orders in an Amazon RDS for PostgreSQL. Single AZDB instance. Management wants to eliminate single points of failure, and has asked solutions architect to recommend an approach to minimize the database downtime without requiring any change to the application code. Which solution meet these requirements? So, minimizing downtime, eliminating your single points of failure, no application code changes, right? And basically, this no application code changes is a very big point. Big point. Why? Because this might be a decider between a lot of options. And they're using single AZ. So let's see option number A. Converting the existing database instance to multi-AZ deployment by modifying the database instance and specifying the multi-AZ option. I mean, this is very easy. You just why? Because AWS makes this incredibly easy, right? You can simply modify your existing RDS single AZ, whatever instance you have, into a multi-AZ deployment in a single click, right? Now, multi-AZ, it will create an automatic synchronous standby instance in another AZ. I mean, uh, that's like a standby instance, and that will kick in immediately if there is a problem, and it requires zero changes to your application code, like the question asked, right? So it's very easy to do, and I think that's the ideal option for this question. B says that create a RDS multi-AZ deployment, take a snapshot of the current RDS instance and restore the new multi-AZ deployment using the snapshot. Now, this might technically work, but it's overly complicated. I mean, taking a snapshot and restoring it requires downtime and configuration changes, which we do not need, right? So B is not going to work in this case. Create a read-only replica of the PostgreSQL database in another availability zone. Use Route 53 wait record sets to distribute requests across the databases. Now, read replicas in PostgreSQL on RDS are exactly that, read only, right? They are reading purpose. They are used for reading purpose. But here, that's not the problem over here. Here, the problem is eliminating the single point of failure, and that is only possible if you have something else in another availability zone, for instance, right? So C is not going to cut it. D says that put your PostgreSQL database in an auto scaling group with minimum group of size of 2. Use Route 53 weighted record sets to distribute the requests across instances. See, RDS is a managed database service. You can't place RDS itself in an auto scaling group. That's plain and simple. You are not deploying a SQL server in an Amazon EC2 instance and then placing it in an auto scaling group. That is a different story. But here it's a managed service. You can't do this stuff. Okay. Now, question number 147. A company is developing an application to support customer demands. The company wants to deploy the application on multiple Amazon EC2 Nitro-based instances within the same availability zone. The company also wants to give the application the ability to write to multiple block storage volumes in multiple EC2 Nitro-based instances simultaneously to achieve higher application availability. Which solution will meet this requirements? So, Nitro-based EC2 instances, Nitro-based, this is very important that they have mentioned this, that is the Nitro-based EC2 instance. Then multiple EC2 instances need simultaneous write access. That also it is there in the question. Now, what we should do in this case? Now, another important thing to notice in the question is um, ability to write multiple block storage volumes in multiple EC2 Nitro-based instances simultaneously. So sometimes when you think of all the stuffs, you would easily answer the question because you are noticing all the important points in the question. So don't blindly read through the question. Always notice what are the important points in the question. Anyways, that is all. Let's go through the options. Option number A says that use general purpose SSD EBS volumes with Amazon Elastic Block Storage EBS multi-attach. Although GP3 volumes are fantastic, they are versatile and cost effective, they do not support multi-attach. Simple as that. So GP3 is out of the question. Second option, HDD volumes I can see, but HDD volumes don't support multi-attach. So I'm just going to reject that. Option number C says that IO2 provisioned IOPS EBS volumes with multi-attach. That's absolutely perfect. Why? Because AWS specifically supports multi-attach only for this IO1, IO2, and IO2 block block express. Yes, block express. So you get your ultra high performance in IO2, low latency storage. Designed, it's exactly designed for workloads that need simultaneous multi-instant write access, whatever this question is asking. So this is perfect, right? And it supports multi-attach that we need. So one more tip when you go in the exam is that whenever you see some simultaneous multi-instance block storage access, right? It always points to this multi-attach feature of EBS, right? So whenever there is simultaneous writing or simultaneous you know some operation is happening on a particular instance, you should always think about multi-attach. Okay, I hope that is making sense. So that is the thing. GP2, I mean, it's already the older version of GP3. So I mean, if you are not going with GP3, then obviously you should not go with GP2. That's common sense, right? 148. Okay, so a company designed a stateless two-tier application that uses Amazon EC2 in a single availability zone on Amazon RDS multi-AZ DB instance. The new company management wants to ensure the application is highly available. What should a solutions architect do to meet this requirement? So, what is this question asking? Single AZ, currently it's single AZ EC2, so single point of failure. RDS is already multi-AZ. Okay, RDS multi AZ, so we do not need to do anything with this. App needs high availability, right? High availability is needed. I mean, multiple AZs are essential. So basically, this is also a DR related question, disaster recovery. So let's go through the options and see. This is very common format of question that is nowadays being asked. One is AWS organizations, and second one is DR. So these are very commonly asked, at least nowadays. That's why you are seeing so many questions regarding in this topic. But the more you practice, the more you become better. Now, option A says that configure the application to use multi-AZ EC2 auto scaling and create an application load balance. You know what? First option, I will keep it as a correct option. Why? It's the most straightforward solution, right? EC2 instances behind an ALV across multiple AZs it's like a textbook definition of a highly available architecture. So if one AZ has problems, auto scaling immediately handles it by spinning up, instances in another AZ. And ALB does what ALB does. It automatically reroutes the traffic to the healthy instances, right? So, you know, it's the best solution, I would say. Option number B, configure the application to take snapshots of EC2 instances and send them to a different AWS region. What is this? It's just absolutely incorrect. Snapshots are used for backups, right? And it will not act like a, failover situation for this particular scenario. So not going to go with B as well. C says that configure the application to use Amazon Route 53 latency based routing to feed requests to the application. Latency based routing. What is it used for? First of all, think about that. So it's used to direct traffic between multiple regions or endpoints based on the latency. But here, your EC2 instances are in a single AZ, so there is no point of using latency-based routing, and it will not eliminate your single point of failure anyway. So that just doesn't make any sense. Configure an Amazon Route 53 rules to handle incoming requests and create a multi-AZ application load balancer. I mean, you are telling, but this might also be a correct option, you might think, but you know what? Not gonna go with that. Why? Because you are making Route 53 handle requests and you are creating a multi-AZ ALB. I mean, it sounds appealing, but it misses a very important point, auto scaling. You absolutely need multi-AZ auto scaling to automatically recover and scale instances across your AZs. And that should happen when there is an issue or a disaster. So Route 53 alone is not needed here, right? So Route 53 is not that you get. So Route 53, one thing to remember, people get confused is that Route 53 is not a replacement for ALB. Can't replace that. So that is one thing. Question number 149 says that a company is using AWS organizations. A member account has purchased a compute savings plan. Because of changes in the workloads inside the member account, the account no longer receives the full benefit of compute plan savings plan commitment. Company uses less than 50% of its purchased compute power. So what is this question asking basically? So they are using AWS organizations. Compute savings plan was bought for one member account. Okay, single member account. Savings plan is not completely fully utilized. They are not, so they have less than 50% of the utilization. So what is our goal? Basically, spread the savings to other accounts if possible, without complicated migrations or other stuffs. But yeah, that's what we need to figure out for this question. So question number sorry option number A says that turn on discount sharing on billing preferences sections of the account console in the member account that purchased the compute savings plan. So discount sharing cannot be enabled at individual member account level, first of all, right? It's controlled from the organization management layer. I mean, the organization management account, it is controlled from there. Member accounts simply don't have the, have that authority, right? It's like You're asking a person sitting on a plane saying that, you know what, the pilot is going to sleep, so you drive the plane for some time, right? Doesn't make any sense. So I'm not going to go with A. Okay. B says that turn on discount sharing from the billing preferences section of the account console in the organization management account. That's what I was talking about from the previous option. So B is correct option over here. C says that migrate additional compute workloads from another AWS account to the account. That doesn't absolutely make doesn't sense. It's just highly complicated and irrelevant to this situation. Sell the excess savings plan commitment in the reserved instance marketplace. Now, if you see, they might find that this also is a better solution, but it's trying, to confuse reserved instances with savings plan, right? But savings plan can't be resold. Remember that savings plan can't be resold in the reserved instance marketplace. That is for reserved instances only. Okay. So once you commit to a savings plan, it's yours. You either use it or share it across your organization. So it's better to share it than to sell it, even though you can't sell it. So I'm just, blabbing about nothing. Okay. So D is also not considered for that scenario. Question 150, the last question for this particular video. The company is developing a microservices application that will provide a search catalog for customers. The company must use REST APIs to present the front end of the application to users. The REST APIs must access the backend services that the company hosts in containers in private VPC subnets. Which solution will meet this requirements? So what does this question ask you? Front end is there. Front end, okay, front end, yes. Front end is there and it communicates explicitly through through REST APIs. That's why I marked that. Not WebSocket. Okay. So backend runs on ECS containers and private subnets. It's here. API gateway must connect securely without exposing the backend publicly. I mean, you need some kind of a private VPC link, right? So let's go through the options and see. Design a WebSocket API by using Amazon API Gateway, host the application in ECS in a private subnet, create a private VPC link for API Gateway to access Amazon ECS. You are explicitly set to use a REST API, not a WebSocket. So why are we going with this solution? No. B says that design a REST API by using Amazon API Gateway, host the application in ECS in a private subnet, create a private VPC link for the API Gateway to access the Amazon ECS. That's what I was talking about, using private VPC link. So you create the REST API via Amazon API Gateway, right? So your REST API is sorted. Backend runs securely on ECS containers within the private subnets that is already there. Private VPC link, it securely connects your API gateway to your ECS containers and you're not exposing them publicly as well. So that is absolutely perfect. So B is very nice. Option C says that, okay, the same thing. We don't need WebSocket API. And option number D says that design a REST API by using API gateway, host the application in ECS private subnet, create a security group for API gateway to access ECS. It's very close, and the security group thing might, consider, it might force you to consider this option. But API gateway does not directly use security groups, right? I mean, to access the ECS backend services. API gateway itself isn't assigned security groups directly, right? So if you want to connect your API gateway, you connect it via private VPC links. If it was a case with EC2 instances or something like that, then you might consider using security groups, right? Hope that is making sense. So D is not going to work for the scenario. So B is the correct option. Okay, so that's it for this video, guys. We're going to meet in another video. Obviously, we're going to continue this series, and I have introduced a new series a course on Azure administrator AZ104, and I plan to make a lot of videos in that as well. So if anyone is interested in that certification, please check it out. I will try to make um, as much as good content as possible, which will help you to crack that certification. And yeah, let's see what happens. Okay, till then, have a nice day. Take care and bye bye.